Hello friends, welcome back to the It's a Guitar YouTube channel. We are here with the 1963 Vox AC10 and it's go time. Time to actually get some work done to this thing. So we're going to try and get this situated on the workbench here. Basically the game plan, I've got all the parts I think I need here. Game plan is to replace all of these resistors with carbon comp, so it'll be carbon comp all the way across the board. We'll likely replace both of these spray caps. We'll redo the 3-prong. And the input wiring, we'll play with that a little bit and see the changes like I mentioned in the last video. And then on the bottom side, clean it up a little bit, move the plate resistors out of there, test that, probably add some screen resistors. So yeah, a pretty full load here. And I think first things first, we'll just remove the 3-prong, just so we have a little bit more room. We'll leave the original foot switch as is for now. Although I might, no, I'm going to leave it. Okay, we got some work to do. Let's get to it. So order of business here, there's a lot to get done. The big glaring thing, I don't know if I mentioned before, these are heater wires. Whoever installed them didn't even take the time to twist them. They're running from the top through here down to the bottom, and that's just not necessary. They can connect right here to the lamp. There should be enough room in the eyelets to fit one more lead each, and they can be very short. So that's going to happen, but I'm going to save that because that's going to be a bit more tricky to do. But really the big thing here, all of these resistors I already mentioned, these resistors, the original ones, they look pretty poor, but they all test fine. So we're going to leave them. And when I say test, I mean with a multimeter. Once the amp is going, we'll have to see if some of them are noisy or causing problems in the vibrato channel like we talked about before. But as a baseline, we're going to swap everything that's not a carbon comp with the carbon comp and then circle back and see what that looks like. We're also going to replace these caps. I might be able to salvage these. This one actually looks okay. This one, let's see. Yeah, this one was just soldered in really poorly, so I might just clean this up and save that. These two will likely get replaced. I'm not sure if we can retain this clip or not. That's not a big deal either way. We'll figure that out. But let's just get started on these resistors. So plan of attack, I'm going to work hot. So I'm going to have the soldering iron turned quite a bit up, and we're just going to flow some solder. Now, all of these were touched up, obviously, recently or semi-recently in the grand scheme of things. So they shouldn't have any problems with the solder flowing. All the original ones, you can see it's got the red paint. Those do not want to flow and are much more difficult to get going. These should be easier, but still, we'll just hit them with a little bit of solder just to kind of remind it to flow. And then once it's flowing like that, then we can go ahead and take the wick. I realize the one I'm trying to show you can't even see. All right, I'll do this one right here. So we'll just kind of hit it with just a little bit of solder, get it flowing like that. And then we're just going to take the wick to it. Just like this. We're not putting any pressure. We're being really gentle. And yeah, pretty straightforward. And then to be extra cautious as well, like I can see there's a bend on the resistor. They kind of bent it over. Now, if I were to try and pull the resistor out, it's going to break the tag. So I'm going to snip the resistors as well and then pull them from this side so that we don't have this trying to bend on the tag. So just little things like that. You got to just take your time. You're going to use a lot of wick on these. But I really enjoy working on these old Voxes. I just think these are the coolest amps ever. So let's get to it. I'm going to start from this side over and take our time. So you don't have any good recommendations for these kind of clippers. The ones I have are terrible. I don't know if you can see the teeth are just torn up on them. So regarding the resistors we're using, it's going to be a variety of vintage resistors I have on hand. The problem with the modern carbon comps is I just don't trust them. The only resistor I've ever had fail that I did a swap on an amp was a modern carbon comp resistor. And thankfully it was on a friend's amp, so he was able to bring it back over and I could fix it pretty easily. But yeah, that just really kind of soured my opinion of the modern carbon comps you can get at all your typical places like Amplified Parts. So instead we're using vintage carbon comps. These are known good, and they test just fine. These two in particular are tested 226 and 228K, so more than in spec. All right, that's looking good so far. Now you might have noticed that I did not put hooks in the resistors. And that's because I don't want to risk breaking a tag, whether it's me or another tech in the future. Eventually these resistors are going to have to get swapped, and it's just not worth it. There's almost no advantage. You know, these resistors are very small, they're very light, so I just want to throw that out there for the folks at home. Moving on, I'm actually going to do the other 220K resistor down here because I've already got that resistor ready to go. And then we'll continue down. One thing I didn't really realize at first is that all the original resistors are lifted up off the board. So I'm going to lift up the other two here that are not currently lifted up, just so that kind of matches. And we're back. It's been a few days. That's how it goes with young kids. So we got these two 220Ks to replace. Got those resistors ready to go off camera. I do want to acknowledge that it is very bright on this side and a little blown out. Sorry, there's nothing I could really do with my current setup. So if that bothers you, I apologize. It would bother me if I was watching, so I empathize. But it is what it is. Just like before. Same process. I know some people like to see, you know, the actual work done. Some people just want to skip ahead and make sure you didn't do something catastrophic, and you know, or they're looking for that to point it out in the comments. All good. One thing to note here is the tolerance bands are all over the place in the amps. You've got these four facing the preamp tubes here. You've got all of these facing the power tubes. And then you've got this one facing up, this one, these facing down, all facing down. So it's very erratic. The majority are facing towards me, so I'm just going to do these the same way. But I do want to acknowledge that, because somebody's going to be crazy like me and point that out. And I do want to also acknowledge that there is definitely a chance some of these resistors are not going to work well in this amplifier, in which case we'll swap them. That's no big deal. The way I'm doing it means that swapping them is not hard and not really a big risk on damaging the amplifier, because I don't have that hook like I mentioned before. So we'll see. But I think we'll start here. Start with these vintage carbon comps and then see what happens. Got a new old stock Allen Bradley here, but this is a military resistor, so it's got an extra band on it. So we're going to try and remove that yellow band with a razor blade and the drill. You can scoff at this all you want, I get it. Just had to carefully remove all this stuff. I'm not sure why the tech did it this way. They tried to have the shield for the vibrato pedal, the two grounds for the filter caps, and then this ground, which is a chassis ground underneath the board, all connected right here. But there's two tags side by side, and they're both jumpered, so you could use both of them, no problem. So I don't really understand why they tried to do it all on one. Very fragile. I'm honestly surprised it didn't break just from the heat, because there's so much going on there. But we'll spread that out between these two, so it's less cumbersome on just one tag here. But you gotta be very careful. Now, to get to this 100K, I'm gonna see if I can clean up this ground connection on this electrolytic as well, just because it looks pretty bad. I don't really know what I'm looking at. Looks like there might be some old lead there or something. Just try and clean it up a little bit. All right, we're pretty happy with that so far. Really, the only resistors left we want to replace would be this 220K right here. And then, let's see, one of these, this one right here, this 150K off of the vibrato, to see if that might help that sound better, since it was having some problems. So I got the replacement Allen Bradley for that one. This 220K, this will be a little bit tricky, but let's go and get that one off. All right, that's all the resistors done here. We did note the 150K off the vibrato pot. It measures fine. It was just more a guess that might be part of the noise. So we'll just kind of leave that for now. And next up, we'll have to go ahead and tackle these caps here. I've got the MOD replacements, which are different dimensions. They should still, I think, be able to stack within this bracket, but we'll have to try it out and see how that works. And then after that, what else? We need to do the heater wires, the 3-prong. So yeah, there's still a decent amount left to do, but made good progress so far. Oh my gosh. All right, look at this, guys. So the screw, or the bolt that goes into the castle nut here, was going up against the cap. I don't know if you can see that. Wearing into the cap. Yeah, not great. Whoever installed this wasn't thinking much. Obviously, electrical tape, not great. Heat shrink that wasn't actually heated up, except for the very tip, not great. Just overall not great. Not the worst, but not great. So with that out of the way, we should be able to at least try and fit 2 mod caps in here. Looks like it should be fine, actually. I'm more concerned about the leads not reaching, but we'll see. All right, some time has passed, and I did this off camera. I was trying to play around and see how I want to do the filter caps, having this off to the side a little bit and avoid the castle nut here. Cleaned off the underside, and I ended up just kind of stacking these 2 caps slightly off from each other so that this top one can reach the 22K here, and the bottom one can reach the 22K here, and both will be grounded over here. So I got a little bit of silicone there, so we're just going to go ahead and fish this under here carefully, and if I did it right, it should fit perfectly. Just like that. We want to go ahead and push this down. So now I'm just working on getting the shield for the foot switch in here, and I'm just kind of trimming this into a point that'll fit through the tiny hole of the tag. You guys saw I just added solder to this to make it more solid versus all the strand. Then that allows me to carve it. Just kind of cut out some chunks so that we have somewhat of a mechanical connection in addition to the solder. So now it's actually physically hooked in there. So when we add solder to this, this will be a very solid connection. Pretty happy with that, so we can consider this amp done as far as caps are concerned. I have very little doubt that these are all fine, all of these WEMA caps. They tend to be very, very solid, so we'll check them, but I'm not too worried about that. We will leave the spray cathode bypass caps because those are going to be fine as well. So I did some final touching up of this cap setup. I swapped this over to a red insulation here, and that was just a bit longer since the other one was a little short. All of this is looking really good. Very happy with it. I did want to point out one thing when I was kind of looking at this a little bit more last night with the input wiring. The AC10 has very weird input wiring, and this one I thought was original until I looked at it. You know, I just kind of glanced at it originally and just assumed it was original, but then when I actually looked at it, I was like, okay, obviously these 2 wires have been replaced. You know, you can see a very clearly different look than the others, and you can look at the solder joints and see they've been replaced. But then if I look closer, there is bus wire that goes from the ground lug to the switch tip lug of these 2 jacks that's been cut. So there used to be a ground wire going from here to here and here to here, and there was no connection from one jack to the next. In other words, there would be no high input and no low input. They both be the same. And that is in addition to the weird wiring with the 220Ks, so it's already padded down a bit. So yeah, the AC10 just has weird, very weird input wiring. This changes the plan a little bit. We were going to kind of A/B before and after the original, and then kind of do the mod I mentioned before and see if that does anything. I got to rethink this a little bit. Probably going to disconnect this. I guess I can add a easy little jumper wire to get it back to factory stock, and then we can test it before and after. I'll have to think about it, but I just want to point it out because that was news to me. I didn't realize what had happened here. So anyways, from here, we can kind of move past this top section. There's still more to be done. There's a helicopter in the background. I live by a military base, so pretty common. Heater wires will have to go here. I'm not going to do that right now. I need to really focus on that to not burn anything. So we'll put that off to the side. And then the 3-prong as well. That'll be the last thing we do. So with that, I guess we can go ahead and flip it over and start on the underside. On the underside here, there's not a whole lot to be done. It's already been recapped, obviously. We got the heater wires, so we're going to be removing those and moving them up over to the bulb here, so we don't have these long runs. The main thing is just these two resistors right here, these 100 ohm resistors that are coming off of the anode or plate of the output tubes here. And then you got the output transformer wires, these two yellow. We're just going to replace those with a wire. And then when we want to do some testing, we can jumper in a resistor, 100 ohm resistor, to see what that does exactly, if it changes anything really noticeable or not. But yeah, just something. I mean, this is exclusively a feature of the AC10, not on any of the other Vox amps. There would be screen resistors, which this does not have, and we'll also probably add those in. But anyways, we're just going to remove these for now and replace with wire. Okay, we got the jumpers installed. I did leave them a little bit long, so there's a part that we can hook on a resistor to test that later, and we can just lift this side out, no big deal. Yeah, everything looking pretty decent. This is kind of a mess, so I'm going to remove solder from here and clean this up a little bit here as well. We might end up moving this ground connection somewhere else, but I don't know, the amp didn't seem very noisy to me, so it's probably fine. And then we'll undo some of this, so let's just speed through that a little bit. Next on the list would be the heater. So I've already taken the bulb out. We're just going to go ahead and disconnect the existing wires. Now, I'm not sure if you can see this. The insulation has started to fall apart on the end. This is from heat, having too much heat, and solid core wire, so it holds the heat, and the insulation is really fragile and not heat resistant at all on this original wire. So that's pretty typical. I don't want to replace the original wire, but I do think we might just add a little bit of heat shrink on the end just to protect that. But we're going to remove both of these wires and this wire right here to just make sure we can even fit the two additional leads here. It's going to be a tight fit. I think we'll be able to do it. Now this black wire is not original, unfortunately. So that one has been replaced, but we're going to keep the originals that are in there. So it's really not a very big hole. We're not going to be able to fit more than two leads in that. Certainly not something big like this, which is why it was tacked on. But we can do, as you can see, it's got kind of an indent on here and here. We could just wrap a lead around that, and that would be totally fine to get mechanical connection as well as the solder. So I think that'll work. I do think we'll have to replace this black lead. Let me see if I have any more brown that could work. I just used some of it for the plate connections that you guys saw. Let me see what I got. I think we're in a pretty good spot now and just can kind of focus on doing the 3-prong with a new cable. And pretty much good to go. We will have to build a junction box for the different outputs. That's not a big deal. So we'll focus on that in a bit. But yeah, pretty solid. Our list is shrinking here. I just removed the hardware. This is holding on the 3-prong. And it's quite grimy and gross, as you guys can hopefully see there. And below this is the tag strip, which is the artificial center tap ground, as well as the HT from the power transformer in the ground. So we're just going to clean this up, make sure it's really solid connection. I'm not sure if you can see. If I zoom out a little bit. Over here, there's another bolt. This is holding this kind of aluminum piece of the chassis to the steel bottom piece of the chassis. So we want to make sure that's really secure. And then this is the other one right here. So we'll make sure those are nice and tight. And you can see there's a little bit of bend in the chassis. It's completely normal. They all do that pretty much. So we just want to make sure it's tight and then good grounds. And then for the 3-prong ground, we're just going to do this spot right here and we'll clean that up a little bit. But yeah, we're making good progress. Here's what the bolt looked like, just covered in wax. So not a great ground connection here. We can do better for sure. This is the layer of gunk that was between the chassis here and the tag strip. So not a good ground connection. Surprisingly, the amp wasn't that noisy, but this is not great. Fought me a little bit, but we got the main hardware holding the two together tightened up, and I added another lock washer on the other side of this to really just get it to lock in place. So that's not going anywhere. And yeah, nice clean solid ground. So we're gonna go ahead and get this ground connection set up with a new lug. Grab one of those, one of these units, which actually fits, unlike the original, which was way too big. You can see how the chassis has bowed. That is completely normal. They basically all do that. And then you can also see here they used a like a self-tapping sheet metal screw to hold in the fuse, which isn't ideal, but is what it is. So the 3-prong we're using is an 18 gauge SVT style, so it's thinner, smaller, fits in this just fine. And we're going to be going hot fused, going through there. We're going neutral to this side of the switch, and then obviously ground will be going here, and ground will be the longest of the 3 lugs. So just kind of mocking it up right now. That's the 3-prong done. Just need to throw the fuse in. We should be good to go. I think it's a 1 amp fuse in it. 1.5, 2 amp is probably better. Let me see what I got. Oh, never mind. It was a 2 amp. That should be fine. I've got a temporary speaker jack wired up here to the 8 ohm output just so we can test things. But the final plan is actually to use one of these ABS plastic enclosures. You can see the code number here. This is what I did to mine. You guys will see that in a future video. One thing I want to quickly note for anybody watching, I already talked to the owner about this, but the choke here, I removed the electrical tape that was covering these 2 leads, and I already talked to him about this. Do not touch this. If you guys run into one of these amps, be very careful because this is connected on one side, is connected to one of the filter caps, and then the other side is connected to the other filter cap that makes up the dual can cap here. Meaning when the amp is on, you got high voltage here. And when you have the amp off, if this is not discharged, you're gonna get high voltage here. So very dangerous, kind of crazy that they had it set up like this way back then. You know, if you're trying to change a tube or something, you bump into that, you're gonna have a tough time. So just be very careful. Don't mess with this. Don't touch this. Make sure your amp is fully discharged if you happen to own one of these or run into one of these amps in the future. So with that safety concern out of the way, let's go and get some tubes and fire this up. I got it hooked up to the current limiter as well. See if you guys can see just off screen right there, and it's connected to the Variac, so we'll be extra safe. Almost 300 volts on that, so definitely don't want to be touching that part of the amplifier. But no, everything's looking good so far. I mean, it's got a little bit of noise, but nothing crazy. Definitely seems better on the vibrato channel than it was. So we might have a resistor, you know, that needs a little love. It could also be some of the input jacks. We've not touched those yet. You know, I already mentioned what we were going to do there, but just want to make sure we got sound, and we do. So looking pretty good. The owner provided a pair of 6P, 14P tubes, to kind of like Russian style EL84. And so I threw those in. I'm just checking the bias real quick. So we can see plate to cathode voltage. It's about 294 or so. And then the bias resistor was 127.2 ohms, 9.52 volts across the cathode resistor. And that gives us 87% plate dissipation. So it is actually running a bit cool with those tubes. Not bad at all. Just wanted to note that. And yeah, seems to be working okay. Hopefully the mic will be able to pick that up. So there's just, you know, static, rushing water kind of noises in the background, usually indicative of a plate resistor going bad, but the plates are all fine. Well. This is going to be a tough edit for me later on. So much has gone on, so much has taken place, and I didn't film a great deal of it because it was a lot of head scratching, troubleshooting, and I didn't want to fill up 50 gigs worth of video of me just trying a million things. So unfortunately for you guys, I didn't really film much, but I will walk you through everything I did and what the problem ended up being. So normal channel sounded great. The vibrato channel though just had this kind of rushing water artifacts in the noise kind of thing going on, where it wasn't just a regular static when you had it cranked. You know, you hear that kind of idle static noise just like you do with the normal channel. But there was more going on, extracurriculars going on in the background. So that told me there's something wrong, right? There's a component that's not happy somewhere. So that sent me down a rabbit hole of like 5 days of testing and trying things to try and figure it out, and multiple phone a friend instances that I'll get into in a second. But yeah, it was an absolute cluster trying to figure that out. And to be honest, you know, the amp sounded great and it wasn't super noisy when you played it at fairly reasonable volume levels. But once you cranked it, and I know the owner of this amp, he's going to crank it, it was just much noisier than it should have been. And the real kind of nail in the coffin for me was I have my own 64 that has not been recapped, is basically all original. And that one was much quieter and the vibrato channel dimed than this one. So that told me there's something going on here, in addition to obviously just knowing that kind of sound is not normal. So let me pull out the schematic and walk you guys through a little bit what happened. So here's the AC10 schematic. You'll notice a bunch of stuff in yellow. So everything in yellow, I either replaced or I lifted and temped in a replacement. And there's not a whole lot going on here. So I touched basically everything of the vibrato circuit, basically everything. So I'll go through it and walk you guys through everything. All this stuff, all of this stuff right here, this is all part of the trem when it's turned on. So this is not relevant to our problem here, because if the tremolo, the pedal is off, this isn't really relevant. So everything else, though, you can see, if I just kind of quickly walk you through the signal path here, you get your input for the vibrato channel, go to the EF86. You've got the plate here, and then that is going through a bunch of different stuff. You can see it ends up going through all of these resistors and whatnot. It goes over here to this series of caps and resistors, which ends up at the volume pot for the vibrato channel. And then that goes off to the phase inverter and then off to the power tubes there. So you can see I touched everything, and that's what was killing me. Is I literally lifted every single thing that was in the signal path as far as I knew, and I could not get it to go away. So unfortunately, like I said, I didn't really film any of this, but it was a lot of pain. Let me zoom in a little bit. So first and foremost, what I tried, swapping the EF86 tube. I tried 3 different EF86 tubes, and none of them fixed it. I even grabbed the known good one from my personal AC10, the original Mullard, which sounds great, barely microphonic, and that one still had the issue. So I knew it wasn't that. I tried swapping the ECF82 or 83, whatever it is, as well. No change. I swapped the 12AX7 and the phase inverter. Again, Hail Mary, no change. A lot of this stuff I'm about to tell you was a Hail Mary. Now, the sound was controlled by the volume control. So really, that would tell me that it's basically everything before, so between the input of the vibrato channel to the pot. Anything between there could be after there, not likely. Now, if I pulled the EF86, the noise went away. And if I disconnected the tremolo circuit, so the vibrato channel preamp is the EF86, but the tremolo part of the circuit actually uses part or half of the ECF82 here. So pulling that did not fix it. So I knew it wasn't part of that. And I did some redundant tests as well. I'll go through those in a second. So let's just kind of follow the signal a little bit, and I'll walk you through what I lifted. So we can see here the plate right there. That's that line. That's pin 6 on an EF86. Is that 6? Yeah. And so that we can see is denoted by this wire right here. Yes, this yellow wire right here. And so that goes, and these 3 tags are all jumpered together. So you've got this cap, and you've got the 330K, and you've got this 470K. You can see that right here. So you've got your cap, you've got your 330K, your 470K. So the cap's actually over there. So I already replaced the 470K and the 750K right here with new resistors. So those were not likely it, though I did lift them and try and sub in new ones just to quadruple confirm. Also, this was a Hail Mary. I didn't actually color this one, but I did swap the cathode bias resistor just in case that was super noisy. I'm not sure if that would cause this problem or not, but I figured I'd try it. So that was swapped. I even swapped the cap. That's how desperate I was trying to figure this out. So the plate goes through this cap here, and then it goes through this. So these are all tied together. So you got a 1 meg here, you've got another cap, and then that is all joined here, and it goes through this other 1 meg and this other cap here, and then you've got this cap. So this whole area I was fairly suspect on, and I lifted every single one of these WEMA caps here. I don't know if I got that on video or not. I can't remember. And I also, replaced those with Vichets. You'll notice it still got paint on this side because I left this side alone. I only did that side just to try and keep it looking nice on this side. And I put in some Vichet replacements. That did not fix anything. The 1 megs, I replaced this 1 meg because I was fairly confident it was this one. Ended up being wrong. I did not replace these, but I lifted these ones. No change. It's important to note that I was replacing the resistors with, not carbon comps for all of these, because when I was doing the temp in ones, because I wanted to use something that, should be silent, shouldn't have any problems. Carbon comps can have problems. I'll get into that more in a second. Swapped this cap out, lifted this one as well, just in case. This 330K is basically the input for the tremolo circuit. There's a lead that goes under the board that goes from here over to here. And so lifting this out actually disengages the whole oscillator tremolo side of the circuit. So I lifted that out while I was doing testing as well. That did not fix it, so I knew it wasn't part of that. Even still, I lifted resistors because I was so desperate. I lifted this one, nothing. This one was already placed, nothing. So yeah, tough. You pull this tube as well. Like I said, that did not help. It got to the point, guys, where I even temped in a new volume pot here and just kind of moved this and this over to a new pot just to see if that would help. That did not help. I muted the grids. So I muted the grids to ground to see if it was the inputs. It was not the inputs. I tried so many things. This cap right here, I tried temping in a new one. The resistor, this is where things get interesting. So this resistor right here, I'm not sure if you can see that. Can you see it? Yeah, just barely. This is 150K resistor. Now I replaced that one. I temped in a new 150K. I have two new old stock Allen Bradley 150Ks. I temped in one and that did not make any change. So at that point, I had done everything. There was nothing left, to my knowledge, that it could be. I even tried, I use a signal generator and a scope, try and follow the signal path. And, this, I think it was this 1 meg resistor was taking the vibrato input or the vibrato channel signal and putting it into the phase inverter, something, or out of the phase inverter. I'd have to follow the schematic, but I even tried lifting these resistors here to see if it was that. Totally shouldn't be that, but I was at that point where it's got to be something. I'm missing something here. So I ended up contacting and talking to Lyle at Psyonic Audio. And you guys, I'm sure if you know me, you know him. He is extremely knowledgeable about these stuff, especially vintage Voxes. He's had a ton of experience with these. So he gave me a couple suggestions, things I'd already tried, like muting the grids, lifting the 330K, etc. And what we ended up doing is he had an idea of, let's take a cap, 0.1 cap like this, and run it to ground and disconnect the 150K off of this this first pin here of the EF86. So let's go ahead and do that. Let's see what happens. So we did that, and we also lifted the 330K again. So just basically completely disconnecting the tremolo, disconnecting the trem pots, all of that is out of the chain now. Suddenly, noise gone. Eureka. Okay, so we've made significant progress there. We've figured out it's got to be somewhere with that. So I thought, okay, maybe it's the pot. And if you think about it, it's not that far-fetched. And this is, again, more experience. You kind of start to know these things. This amplifier's got a very unique trem circuit. And it's got a really cool trick where you take the amplitude, and if you dime it all the way up, you get a huge gain boost with the EF86. That's because this is affecting, I guess, the plate voltage. And this pot will actually have 50 volts DC on it when it's maxed out. So there's DC on this pot, which, as you guys know, DC can wear down pots. So it could very well be the pot going bad. So I temped in a new replacement pot with the same cap here, and I also temped in a new 150K. Now here's the key. I used the other 150K. So remember I said I have two Noel stock Allen Bradleys. It's a weird value, 150K. I used carbon comps for that because it's a weird value. So the 1 megs, the 330Ks, whatever else, I used resistors that were, Vishay power metal films, for example, that are going to be dead silent and not have those issues. I only had carbon comps for 150K. Now, granted, I could have used 100K or something else, but I didn't think about it. I didn't think it would be a problem. So it was that fixed it. So the noise was completely down now. Fantastic. Okay, maybe it's the pot. Just to double check, I tried the other resistor with the new pot, and the noise came back. So, oh my gosh. Okay, so there you go. It was the resistor. Now I did also clean the pots with deoxit. I hit this pot with some more deoxit before doing that second test. So that could have helped a little bit, but for sure that resistor was super noisy, in addition to the original 150K, which was extremely noisy. So this was the cause of the problem. My replacement was also a cause of the problem when I temped in a new one, and it happened to be the second one I had was the fix. So thankfully, the original pot is totally fine. Do not need to replace that, which is awesome. You don't want to replace original pots on vintage amps. And with that, we solved it. We fixed the crisis after many days and many hours of just troubleshooting and lifting almost everything on the board and putting in a new one just to quadruple check things. So that was a lot, but that was a lot of work behind the scenes that you guys did not see. So I wanted to get you up to speed. Now, I'm going to go ahead and end this series, not the series, excuse me. I'm going to end this video as part of the series here because there's been so much leading up to this, and the video is just going to be way too long. So the next episode of the series, what we're going to do is what we talked about. We're going to, you'll also notice, sorry, I don't know if I even said this before. You also notice I removed the jumper wires that were done to modify the inputs, and I returned them back to stock. So I temporarily added in bus wire to the stock location so that this is effectively stock now. That way we can go ahead and do the test in the next episode of the series where we'll play with the inputs to get it closer to like the AC15 spec or AC30 or basically any other amp. It was really just the AC10 and maybe like the AC4 or something that had this weird input wiring. So we'll see if that makes any change to the tone, favorable or not. And then we'll also take another look at the plate resistors here off the output valves, the 100 ohm or something, which is going to just pull down the power a little bit. I want to see, we'll run it on a scope. We'll see what kind of max clean wattage it's putting out. And I've got just those jumper leads you guys saw me do. We'll test that as well, and then temp in some 100 ohms just to see if that makes any change to the tone or the output. So we'll do the next episode being that more experimentation, but otherwise this amp is sounding incredible. I'm extremely excited by it, and it's really invigorated my love for these old Voxes despite being a massive pain and fairly difficult to work on if you don't want to break anything. So with that, thank you guys so much for sticking with me here. Appreciate you watching. Like the video if you enjoyed it. Subscribe for more, and until next time, see ya.